So we have this one here that we're gonna solve with the method of sections, okay? So it's a typical problem of trusses. Well, I was gonna say typical. Well, it has a little bit of differences that I will comment right now. But so far, this is a truss. We notice that we have at a pin support, and at E we have a roller, and we have the points here, A, B, C, G, D, all of them, and it's being pushed down by some forces that I'm going to put over here, which are magnitude P, and magnitude P. So look at it. We don't have too many numerical values. Maybe we cannot get this thing with numerical values. But so far the magnitude is P, the magnitude is P, and the magnitude is P. And the distances are also without numerical values. It's just with letters. So L, 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 L. And look at the height. The height is L divided by 2, and L divided by 2, this distance from here to there. And they're asking us to get BC and to get BG. That's the thing that we need to get in this problem. So I'm gonna start right on by doing equilibrium to D. Okay, so equilibrium to D. For some cases it's mandatory, and for some other cases it is not. So let's have a look at this. I'm gonna do X, something at X. Oh, okay, but I'm missing to put the free body diagram completely. So I'm gonna put it right here, which is this guy is going up, its name is AY, and this thing going to the right, which is gonna be called AX, okay? Now for this roller, I have a normal and its name is gonna be NE. That's it. These three guys P, they are not unknowns, these are not supports. So X, I'm gonna have AX going to the right, and nope, 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 none of them is going also left or right, therefore equals to 0. Well, that wasn't that difficult, okay? So I'm gonna go with Y. So the Y part's a little bit more difficult, but let's just go. AY plus the normal at E should be equal, maybe you see it, well, let me just put minus P, and minus P, okay? So equals to 0 because all of these guys are going down. Therefore, I have for this equation that AY plus NE should be equal, NE equals to 3P, okay? So maybe not that complicated, but that's how it is. Okay, so now, not known and not known. P is not known as a numerical value, but it seems that it's part of the data of the problem, therefore I know it. So maybe these guys are gonna be in terms of P. So we're gonna see what happens next. So I'm gonna do moment regarding A in order to get all these three equations for the equilibrium to D problem. So what I will have over here is that, for example, P times L, okay, this first P times L, so L, and maybe you see that this guy is a negative. Later, P times now 2L, okay, because I need to move myself, not just one L, but two L's to find this P over there. So it's minus P. And also I will have the P times 3L, okay? So minus. And finally, for this moment regarding A, I will have NE multiplied by 4L, okay, equals to 0, and maybe you detect that this guy is gonna be positive according to our right-hand rule, okay? So that's the thing. Now, maybe you see L just goes out because this equation doesn't depend on L, but I'm gonna get that NE equals to 4 down there because of this 4, and all these guys that were negative are going to be positive over there. So maybe you see that I have 1 plus 2 plus 3, so that thing is a 6P. Therefore, I don't know how to put it this long line, but therefore NE equals to 3P divided by 2, wherever the units are. I think they are kilo units, but it actually doesn't matter too much. Therefore, I already have how much is the value for NE. It's 3p divided by 2. Now, with that information, I can go back to this equation and finally say that AY is going to be equals to, maybe you see this, 6p divided by 2, which is this thing over here. I just used it in order to put the NE minus NE, which is 3p divided by 2. And this thing should be equals to 3p divided by 2. Therefore, AY is also 3p divided by 2, okay? So maybe you see that this thing, this truss is symmetric. So this thing AY equals to an E. Well, okay, so I found it. This has nothing to do with the method of sections. Now we're gonna see about the method of sections. Okay, so first of all, do the section, okay? We need to do the sections. I need to find BC, okay, so this one, and BG, okay, so this one. Okay, so I'm gonna do this section from here to there. Hey, buddy, but you know what? You did FG too. Well, I don't mind. I have 3 unknowns and I can use 3 equations, so I'm safe using that. Well, okay, so by doing that, I'm gonna choose a side. Which side am I gonna use? I'm gonna use this side over here. Now I will look at the problem from here to there. So this is what I will look in the method of sections. So here is my section. Therefore, I will see some like this. Maybe I can do it my best to not screw this drawing and be as clear as possible or something like that, okay? So, well, after that, maybe I can do this as the best as I can. Something like that. I wanted this as vertical as I could. Okay, so I have. Now, this point is A. I have these sections. So let me just put whatever I know. So what I know over here that this thing is 3p divided by 2, okay? And AX equals to 0, so I won't put it. This point over here, I will see that there is a P going down at here at point F, fine. And let me see my unknowns. So I will have this unknown. Its name is TBC. I will have this unknown, as horizontal as I can do it. This is called TBG. And there's also, oh, I think I screwed the drawing here. Yeah, I screwed the drawing. It shouldn't be this way, but I think I can fix it as, I think I can fix it somehow as fast as I can. Something like that. Okay, I think I got it. Okay, so that wasn't much of a problem. So from here to there, this is the one that I'm looking for to do this body over here. So I will try to put it like that, okay? So I don't want to put it too close to PG, so I'm gonna put it like that. So it's gonna be called TFG. Okay, fine. Now, from here I have my set. This is my problem now. My problem is to get TBC. I need to get this thing and I need to get BG and maybe just for the sake of it, TFG, okay? So what would I do? Maybe I can use X equation, but you will see that X equation is not the best idea because this TBC has a part at X, TBG has a part at X, and TFG has a part at X. So X is not that it's wrong, but it's just not the wisest of the choices. What about Y? Well, Y maybe is not that bad because this TBG won't appear in that equation, but this guy will appear and this guy will appear there. So, well, maybe I can skip that part using the moment equation. That's why this is the thing about the method of sections that I can use a moment. So the moment that I'm gonna use at first is moment at A. So I'm gonna use moment at A equals to 0. And you will say, hey, we already used moment at A. Well, yeah, that was for the whole structure. Now I need to do to just one part of the structure over here, okay? So I'm gonna do that. So this 3p divided by 2 doesn't appear because it passes through A. Now let me just see about this P. So P times L. Oh, again. Well, yeah, again. So I have it over there, and this would be a minus. Now, what about these unknowns? Which one appears or not? So maybe you see that TFG is passing through A. So I won't put it. Hey, what about TBC? Well, also TBC will pass through A. The only one that doesn't passes through A is actually this horizontal that is called TBG. So I'm going to put TBG times a distance. Okay, so how much should I move myself in order to find that? Let me look at it. This is what I'm looking for, okay? So from here, this is the one that I'm looking for. From here to there. Now you see that from the data of the problem, I looked at all this distance is L divided by 2. So I'm going to put L divided by 2, and I will get that. So now I need to decide the sign. And the sign, maybe you see that this thing is going to be a minus. So equals to 0. Again, L and L just goes out, so I don't care too much. And then TBG, which is one part of the things that they're asking us. So TBG is actually this minus will pass this other way, but I have a minus over here, so it will still be a minus 2P compression. Okay, so the units are not that relevant at this point, but at the end, they should be relevant. Okay, so I'm just doing some artistic stuff in order to get this thing, but I'm wasting my time and your time too. So, okay, good for us. Now we already have this guy over there. What about the BC? We still haven't got that one. Oh, can we do some simplification? Well, let's just look at it. What happens if we do another problem, I mean another moment equation, instead of using X or Y, what about doing another moment? So maybe it's a good idea. Let's just discuss this. This point here is P. Hey, what about if we do moment at B? If I do moment at B, this TBC cancels out, this TBG cancels out. That doesn't seem a bad idea. But the problem is that I want to get TBC. So, oh yeah, you're right. I shouldn't be using B because I will cancel out the one that I'm looking for. So maybe I can use F. Maybe I can use F in order to do that. So I'm gonna do that. So moment regarding F equals to 0. Okay, this should be an F. Okay, so moment regarding F equals to 0. So now, what do you think it will appear? Let me just see. 3P divided by 2 should appear. So I'm going to put 3P divided by 2 times a distance. Okay, maybe you see that this distance from here to there is L. So L. Positive or negative, according to my right-hand rule, this should be negative, okay? So that's one thing. The P doesn't appear. Let's just see which of these unknowns appear here at F. This guy won't appear, okay, because it's passing through F. Hey, what about TBG? Well, TBG needs to appear, okay, so I'm gonna put the TBG that I already know, fine, and multiply by a distance, so I need to go all this way. Oh, so that should be, I think I got it, right? Well, do you? Well, let me just see. From here to there, I need to get it. So if you look at it, you have data that goes from here to there, but you don't have data that goes from here to there, nor from here to there. So you don't know it. So let me just do triangles, okay? So let me just do this triangle, whoop, whoop. And this triangle would be, for me, let me just see if I can do this part. This guy is F. This guy is here, right in the middle is, I'm sorry, F. This guy is A, this guy is F. And this guy over here is G, okay? So maybe you see that from A to G, vertically, you have as data, L divided by 2. And all this stuff, maybe you see that, this guy is L, and this guy is L, okay? So maybe you see that this is this triangle. Maybe I can simplify this stuff. How? Well, look at it. So I have this, okay? 2L and L divided by 2. Can I go a little lower, or can I reduce these numbers? Yes, I can. I actually can put, if you like, L and this stuff L divided by 4, okay? I divide everything by 2, so I have that stuff over there. And now maybe you see that from here, I will erase this later, but so far, let me just get to this place. I have this 1 and 1 divided by 4. I actually don't care too much about this, about getting the hypotenuse right now. I just wanna see, if I put 1, how much would I get here? Or if I put L, how much would I get this thing? Now I can go back to my problem and see that this distance from here is actually going in the floor or horizontally the L, and this little bit from here to there should be L divided by 4, because this distance from here to there, sorry about the mess, L divided by 4. So therefore, this guy should be L divided by 4. Why? Because all this thing from this floor to B should be L divided by 2. That's how I got it. So let me just erase a little bit of this mess. And that's how I got actually the distance that I need to climb up in order to get it. So let me just put L divided by 4, fine. And I need to decide a sign, so that things could be negative. Is that it? Well, no. TBC is already there, so I need to put it. So how much should I move myself from here to there? So to make myself a little bit of room. So this guy is F, fine. Over here, up here, I have the B, fine. So I know that TBC is passing through here. I need to decompose this in the TBCX and in the TBCY. But maybe you notice that TBCY will pass through the point where I want to get the moment. So this TBCY won't produce moment. The only part that I care about is TBCX. Okay, and again, this distance, it's L divided by 4. I already had it because I need it for the other part, but now I had it for this part over here. So what I can put is TBCX multiplied by the distance, which is L divided by 4, okay? Now I need to decide a sign. This is still minus. So according to F, and we try to move that way, so it's a minus. And now I have finished this equation. This guy should be equal to 0. The only problem here is to get TBCX, So maybe I can do it over here again, okay? The TBC. So I have this line, and it goes from A, it goes to B, and then it goes all over there to C. Okay, now I want to know how much is this. Well, you know, I have L, and I have L here, and the distance that I have climbed up, maybe you see that it's L. It's 2 times L divided by 2. That's this, that is what this slope. So it's 2L here, so I have 2L here and 1L over there. So this is simply, you don't need to know the L, you need to know the ratio. So it's just like you had 2, 1, and you will get the hypotenuse, which is square root of 5. Hey, what about the L? Well, you can do the math and you will see that the L just cancels out if you put something here. Therefore, I'm gonna do it again. So minus 3 divided by 2, minus 3p divided by 2 times L minus TBG. I'm already gonna put the thing that I know. So I'm gonna put minus 2p, got it, multiplied by L divided by 4, fine, minus TBCX, and TBCX is TBC that I don't know, multiplied by, okay, the horizontal part. So you're the horizontal part, so I'm gonna put you here, 2, the square root of 5, okay, and times L divided by 4 equals to 0. Now, let's just do some housekeeping. L just goes out, L goes out, as typical. Now, let me just multiply everything by 4. So I'm gonna multiply everything by 4, and I will get this minus 12, okay, 4 times 3 is equals to 12. 12 divided by 2, I know that I can reduce it, but let me just go this way. I have that times 1 minus everything divided by 4 here just gets me 2a minus 2p times 1, okay, so 1 because I multiply everything by 4, minus TBC, and I had a 4, this 4 is gone from here, that's what I wanted to multiply by 4, so I will have 2, the square root of 5, okay, equals to 0. Okay, there. Now let me just do some housekeeping. Minus 6p plus 2p minus TBC. Oh, some lag. I have some lag over there too. The square root of 5. I think I'm gonna go. I'm going too fast for this thing to follow me. Oh yeah, I'm so fast. And now TBC TBC should be equals to, okay, so this thing is a minus, okay? It's gonna be minus 4p. It's gonna pass here as a plus, but I have a minus, so it's gonna be a minus the other way around. But I have 2, okay? So instead of the minus 4, it's gonna be a minus 2p square root of 5. Okay, so this thing is compression, and this problem has just ended there. Hey, what about the units? Well, you need to go there and see what are the units, but it doesn't really matter. You already have the thing that I wanted you to have. Okay, this is using the method of sections. It's not an easy problem because you don't have numerical values and you need to deal with letters, but at some point it's actually easier than working with numbers. Okay, so see you guys.